In this video, I want to talk about finding the asymptotes of a rational function. So you may remember that rational functions are functions that involve a fraction. So there's a numerator and a denominator. And sometimes there's x in both, and sometimes there's x in just the denominator. But that's basically the most simple rational function is just 1 over x. So I'm going to use 1 over x to start talking about the asymptotes of a rational function. So asymptotes are simply a line that the graph gets closer and closer and closer to, but never actually touches. So on the vertical axis here, this graph gets closer and closer and closer to x equals 0. This is the line x equals 0, right? So the graph gets closer and closer and closer to this line. So this line is x equals 0 because it's a vertical line, so it's an x equals, and it's right at 0. So it gets closer and closer and closer to 0, but it never actually touches 0. That's because no matter how close to 0 we get, we can't divide by 0, right? And the bigger or the smaller this number gets, the bigger this number gets, which is what's happening here. The closer we get to 0, the bigger the y goes, and the y goes off to infinity as x gets close to 0. So this is called a vertical asymptote. And an asymptote is just any line that the graph gets closer and closer and closer to, but never actually touches. So there's also a horizontal asymptote here. So the horizontal asymptote is right here. And this horizontal asymptote is y equals 0. And that's because no matter what we put in the denominator of this fraction, you can't make it equal to 0. Even if the denominator is 10 trillion, it's going to be like a 1.00000, however many zeros, and then a 1. But it's not going to actually equal 0. So it gets closer and closer to 0, but it never actually gets there. That's a horizontal asymptote. So horizontal asymptotes have the form y equals some number, and vertical asymptotes have the form x equals some number. So now we want to figure out how to find them. So as you might have noticed, vertical asymptotes happen when the denominator is equal to 0. So to find vertical asymptotes, you need to set the denominator equal to 0. Setting the denominator equal to 0 is how we figure out what the vertical asymptotes are. The vertical asymptotes are all those places that are not in the domain because they make the denominator equal to 0. And you've been finding those for a long time, right? Every time we find the domain of a rational function, we take out all those points that make the denominator equal to 0. Those are the vertical asymptotes. So you've been finding them for a long time. You just need to, it's just a different use for finding those points. Now, horizontal asymptotes are a little bit different. Horizontal asymptotes are what happen when x gets really, really, really big or really, really negative. So it's when horizontal asymptotes are what happen or what happens when x goes to infinity or x goes to negative infinity. And there are some different cases on what can happen there. So if you ever have a fraction like 1 over x, where the degree of the denominator is bigger, so if the degree of the denominator is greater than the degree of the numerator, like 1 over x, right? There's an x, so the degree of the denominator is 1, and the degree of the numerator is 0. That means that when x gets really, really, really big, we're just going to have some number divided by a really huge number. And that means it's just going to go to 0, right? A number divided by like a million, a billion, a trillion, it gets closer and closer to 0. So in that case, y always equals 0. That's always the horizontal asymptote. And there's only one horizontal asymptote, or there might not be any, depending on the situation. So we don't have to look for more than one. Sometimes there can be more than one vertical asymptote, but there can never be more than one horizontal asymptote. So if the degree of the denominator is bigger than the degree of the numerator, then the asymptote is always y equals 0, because a smaller number over a bigger number always gets closer and closer to 0 as that number gets larger. Now, it can also happen in the case where it's like x squared over x to the third, because if you have like a million, then this is going to be a 1 with 12 zeros, but this is going to be a 1 with 18 zeros. And again, it's just going to get closer and closer to 0 the bigger those numbers get. So anytime the degree of the denominator is larger than the degree of the numerator, then it's always y equals 0. It always goes to 0. So if the degree of the denominator is the same as the degree of the numerator, so if the degree of the denominator is equal to the degree of the numerator, then what's going to happen is whatever your leading coefficients are, it's going to be that. So for example, if you have, let me take this away and we'll look at an example. So for example, if we have f of x equals 3x squared minus 4 over 2x squared plus x. Let's just say, so this is our rational function, and then so the degree of the numerator is 2 and the degree of the denominator is 2. And that means that when these numbers get really, really big, these numbers are going to be so much smaller than these ones that they won't really matter. And what's going to happen is the x squareds are going to be the same. So whatever these leading coefficients are, this is going to be your horizontal asymptote. So in this case, your horizontal asymptote is going to be 3 over 2. So y equals 3 over 2 is going to be your horizontal asymptote. So horizontal asymptote is 3 over 2. So the degree of the denominator is equal to the degree of the numerator means that we just take those leading coefficients and divide them. So whatever the leading coefficients are, let's just say it's going to be y equals a over b, just assuming that those a and b are those leading coefficients. Let me write that so you can read it. So let's go ahead and actually find the vertical asymptotes here too. So in this case, we want to set the denominator equal to 0. So we're going to get 2x squared plus x equals 0. So we can factor out an x, and we get 2x plus 1 equals 0. So we get x equals 0, or 2x plus 1 equals 0. And this will be 2x equals negative 1. So x equals negative 1/2. So these will be the two vertical asymptotes in this case. And so when we graph it, it's going to have two vertical asymptotes and one horizontal asymptote. It can only have one horizontal asymptote. So if we have, let's just do this really quick. So when we graph it, we would be drawing vertical asymptotes at 0, and then also at -0.5. So here's -1, let's say. And then we would be drawing another vertical asymptote here. And then we would be drawing a horizontal asymptote at 3/2, which is 1.5. So let's go ahead and do this. So it would be around here. Oops. I'm not doing a very good job there. Okay. So we'll talk more about graphing them in a different video, but in this video I just wanted to talk about finding the vertical and horizontal asymptotes. So to review, to find the vertical asymptotes, we set the denominator equal to 0. Wherever it equals 0, that's a vertical asymptote. In a horizontal asymptote, we're looking for the degrees. So if the degree of the denominator is larger than the degree of the numerator, it's always y equals 0. If the degree of the denominator is equal to the degree of the numerator, then it's y equals a over b, where those are the leading coefficients of those two, of the numerator and the denominator. You just take those leading coefficients and that will be your horizontal asymptote. Additionally, some rational functions don't have horizontal asymptotes, and those are the ones where the degree of the denominator is less than the degree of the numerator. So if the degree of the numerator is larger than the degree of the denominator, they don't have a horizontal asymptote at all, and we're going to talk about those more in a later video, but we'll keep those out of this video for now.